Hey everybody, welcome back. So tonight I'm probably going to just blow up my YouTube channel because we're going to discuss something that I know is going to create some controversy, and it's the structural design of a wing. And I'm not going to get into any math. I'm going to do this in a very kind of a wing 101, but I'm going to talk about how I've done it. These are only my practices, okay? The Google warriors that keep talking about how to build stuff, I feel in my heart they've never actually done it. So there's going to be video on this. There's going to be a whole bunch of really cool images that's going to show wings flexing. So I hope you enjoy this, but I guarantee you I'll probably not answer any negative comments that's on my YouTube. So yeah, let's get this train out of the station. So here is a camera mounted on the wingtip of my Emmaselle II. A couple of things. Most of the video you'll see that I make is either the camera on board or a drone to air coverage of my airplane. I have not learned yet how to hold a radio in my hand and hold a camera at the same time, because people say, why don't I see more video of your planes flying? I don't have an entourage with me, okay? I don't have a camera person that follows me around the country. I would love to have somebody who would show up and do some great footage of my plane, but I just don't have it. But I want you to look at this image. If you look at the other side across the fuselage, you can barely see the wing, okay? In this next image, you can see a lot of wing. So either we're warping the time continuum or we're flexing my wing here. And one of the things that I have learned over the 40 years of doing this, flexing is good. Okay, flexing just means that the energy is being dissipated in other points throughout the wing. Wings that don't flex would make me nervous because nothing's giving, okay? Now, this airplane has a very large, like 7.5 foot carbon fiber 1.5 inch tube running through the fuselage and about halfway out through each wing, and I'll show you a lot more of that in a minute. But I want you to think about how much this is flexing right here. If I go back to this, no flex, pulling G's, okay? So when we talk about the wing design, this wing was something that I wanted to just go completely out of my norm or out of my comfort zone with. I aerodynamically wanted to build a wing where it had more wing area as you went out than it did inboard. So basically my ribs from a third of the way out get really big, and then the wing starts to taper. I did that so that the center section of the wing would quit flying first. So when this wing stalls, I still have aileron authority. It's the coolest thing. It worked, but we're talking about structure right now. So if you look at the two wings here, the one on the right has carbon fiber toe, and I'm going to talk more about that in a minute, on the top of the balsa wood spars. These wings have 1/8 inch light plywood ribs. Say that again, 1/8 inch light plywood ribs. The spars are balsa wood, and the shear webbing are balsa wood. That's all it is. And what I call the joiner tube, or the wing tube, goes about halfway in a span. So if you look at this right here, that's all the far out that my wing tube goes into the wing, okay? If you look at this again, oh, and the green you're seeing there is 3D printed hard points. If you've followed me for any time, I love to 3D print engines for RC airplanes, fake dummy engines. You know, if you look around the perimeter of the video right here, those are all 3D engines I design, and I can 3D print for different aircraft. But the hard points in my wings and sometimes landing gear parts or holding cowlings on, I 3D print all that, and I love to do it. And I'm actually going to do a video on all of that too. But if you look at that rib right there, that's where the wing joiner tube stops. And if you notice, I got some big old holes in those ribs because I don't need the weight. I had a lot of people come out and go, that's the dumbest thing. You're making the wings weaker. No, I'm not. I know what I'm doing. By having those big old huge, if anything, I'm making the rib a little bit weaker that holds up the skin. But structurally, that has nothing to do with the way that this wing mechanically works, okay? So here is the wings when I first test fitted them on the fuselage. All of this area here does not have the carbon fiber wing tube in it. So I have to depend completely on my balsa wood spar design. And I felt 99% comfortable that this was a great design. I didn't go so far out there that I thought it would actually break. But in the back of my mind, and I'm also a little bit paranoid, I didn't know. So when you look at this right here, the black stuff on top of the spar right there is what's called carbon fiber toe. There's a couple of different types of carbon fiber I've used, and the spool on the left is called carbon fiber toe, which is just carbon fiber, I call it string. I use West System epoxy to laminate it to things for strength. Most strength in a wing comes from tension, not compression. And I'm also going to blow up my YouTube channel here a little bit talking about carbon fiber. I have had at least 50 people in the last 10 years say, oh, you should be using carbon fiber on everything. My experience is they've never done it themselves. Okay, and I'm going to tell you why. Now, if you're building a fuselage for a glider and you want to use 1 or 2 layers of the really light carbon fiber twill, I've seen that, and it's sexy and it's really cool. But you got to build your molds. You got to know how to lay up that carbon fiber. As far as doing bulkheads and ribs with carbon fiber for radio control, it adds weight and time and a boatload of money. So I've tried to do bulkheads, which put down a couple of layers by themselves, let it cure, use West System epoxy. Then you got to take a bandsaw or a CNC mill, and you've got to cut your part out of that. Well, first of all, you're throwing away a ton of carbon fiber, which is not cheap. That 51 inches wide, 1 yard long, is about $55 on the internet. Now, you can go to eBay and find it sometimes as low as $35, but I've bought probably 20 or 30 yards of this in different experiments and different designs I've done. If you looked at some of the landing gear struts I've made, I've used carbon fiber, and they work really good on that, but it's not the way you think, and I'll do a video on that. I don't want people to think that they can put down 50 layers of carbon fiber and just make a landing gear. I shouldn't even said that. So, but the problem with carbon fiber is if you're going to cut it with a bandsaw, you got to mask up. You're throwing away all the material in the middle if you're doing bulkheads. Everybody I've seen put carbon fiber on a model airplane has added weight and made it so strong that it's not even necessary. But I do use it to laminate on a spar to give it tensile strength. So here's an example. So this is my son 10 years ago sitting on a balsa wood wing that I was experimenting for my B-36. That wing right there has only balsa wood spars, balsa wood shear webbing. I did some X bracing with carbon fiber toe. The top and bottom spar have carbon fiber toe, and he at that point weighed 90 pounds, and you can see that he deformed the leading edge balsa wood that didn't have any reinforcement on it. And you can see the first spar sags a little bit, the second spar doesn't sag at all. But just the carbon fiber toe made that balsa wood wing that strong. His weight wouldn't break it. We got up to about 150 pounds of barbells on it before it actually broke. So that's where I love using carbon fiber, okay? And I'm not putting down anybody when I say that, these people that are all saying that, you use carbon fiber and you either bandsaw or CNC. First of all, you got to own a CNC. You can get one for about $1,500 if you build your own at home. A CNC mill, or you can buy a real decent one for $10,000. I mean, there's such a range in doing CNC, and it depends on the scale you want to do. For me to CNC a bulkhead for one of my airplanes, most of the smaller CNCs aren't big enough. Not to mention all the material you're going to throw away. So, I hope the people that are having success doing this would post videos, post their success. Show me how you've built a model airplane using CNC carbon fiber bulkheads or ribs and had success. It's also the other day somebody posted that, I should be doing the fiberglass skins. I've done the fiberglass skins. The problem with fiberglass skins is if you put down a layer of 3/4 ounce cloth, then you put the 1.5 ounce cloth on top of it. So basically what you do is you get a big sheet of plexiglass, 4 by 8 feet. You wax the heck out of it with mold release. I like to use, I can't remember what I call it, I call it green goo, but you spray it on and it's a different mold release, but you basically, I can't remember what it's called, but it's a mold release. You spray on the green goo with an air spray, with a spray gun, and then you pour your resin onto the table, and you, at least this is the way I do it, I take a roller and I roll it all out, let the resin start to cure a little bit. Then I lay out my first layer glass cloth, take a roller and roll out all of that resin. Then I lay my next layer cloth on it, roll out all the resin, then squeegee it all off. And you got to squeegee every bit of resin you can get off it. Then once that's cured for 24 hours, you peel that up and you got an awesome skin, okay, made out of fiberglass. It's really cool. The problem is balsa and monocoat weigh less. Okay, even if it's a 0.5 millimeter thick, those 2 layers with the resin weigh more than a light balsa wood with monocoat. And plus then you got to get into having the perfect wing. So if you're going to put that fiberglass skin on your wing, balsa wood gives you a little bit. I'm talking about 0.010 of an inch difference for the balsa wood to maybe dent or push down into the ribs and get it to work right. When you've got a fiberglass skin, you can have ribs that don't even touch the fiberglass. So you put the glue on the ribs, you lay the fiberglass on there, you hold it down. If you got one rib that's a little bit in, if it's a tapered wing, if that rib's in or out just a little bit, then you end up with a huge problem with your ribs all touching the fiberglass, because it's, once you curve that fiberglass, it's a structure. Okay, I'm not knocking it, and I'm going to use it on some projects in the future, but you've got to be so, and it's not cheap. I mean, balsa wood monocoat is so much cheaper than making fiberglass skin. So now I'm going to talk real briefly about my sponsor, RTL Fasteners. I love these people. The screws on the bottom are servo screws. I use those to hold on cowlings and fairings and all kinds of stuff. Blind nuts, washers. They got some neat washers that have this rubber that's impregnated on it. It's just a really cool company. If you need fasteners, go there. And what's really cool is evidently they like me, because if you go there and use DA30 as a code, type into the code DA30, order more than $50 worth of their awesome product, and you will get 30% discount. Okay, so let's continue here. So now we're gonna have some fun. We're gonna watch this wing bend, and then we're gonna watch it from the tail too, because I love to put cameras on my airplanes and see what the heck the structure is doing. So this is me starting a loop, and you can see the wing really bending up there. Now, my fear was the wing was bending on the outside of my wing tube. So if you remember earlier, my wing tube goes about halfway into the wing and stops. I was wondering if the balsa wood out there, so was the wing bending out there? We're going to find out. So I'm still pulling up on the loop here. Okay, oh, notice, of course, at the top of the loop, you're starting to unload the airplane. Okay, and if you're doing a good circular loop, now if you're just going to pull a positive G loop and it's going to be like this, you would see the load on the wing. At the top, you can't even see the other wing because I'm basically unloaded. Okay, now I should have probably gotten off the elevator. I love looking at my elevator input right there, because that means normally at the top of the loop you want to be almost back to neutral. So this wasn't a perfect circle at all. Here we're coming back down the back side, and right here you can start to see the wing. I'm starting to pull load on it, and now we're really starting to crank in the G's. So right there was the maximum deflection. Now at the wingtip, it's about 3¼ inches, and I'll show you how I know that in a minute, because I have a camera on the tail. So this is me coming downhill, pretty much a very light load on the airplane. Okay, so I drew this line here to see, is the wing flexing outside that wing tube? So go about halfway out the length of that wing, and that's where the wing tube stops. Okay, so I really wanted to know, am I flexing the balsa wood, or is my entire carbon fiber spar, and this is insane, that 1.5 inch carbon fiber spar that's almost 8 feet long. I've put it on 2 stands, and I've put like 300 pounds in the middle of it, and it flexes. But what's blowing me away is my fuselage weighs about 51 pounds, 54 pounds, no, 51 pounds. And I bet I'm putting a couple of 100 pounds on this spar. So here is me on the downhill. This is me starting to come up. Now, you'd notice, though, the wing did flex there, but it's not flexing outside of where the wing tube stops. So I don't have any. Now, there is something weird here that I noticed a little bit. It looks like the wing's twisting just a little bit, which I will talk about that in another video because I know what's going on there. So that was it coming downhill. This is it pulling uphill. This is me coming over the top, unloaded. You can, and I'm going to show how I know where the wing's flexing here. If you notice through the entire length, it's not flexing. This is me starting to come down the backside. This is where the G's are really starting to come on. And the wing's flexing, but not at the balsa wood. Well, it's not the wing flexing. It's a carbon fiber tube flexing. And I'll show you in a minute. And this is me under the maximum load as it's coming out. And then, and still under a lot of load. Now, this picture here is 2 pictures that are superimposed, but I've got a much better one I'll show you in a minute. But if you look close, you can see how much the wing flexes. And it's insane, but it's the entire wing at the fuselage flexing. So my carbon fiber going through the fuselage is doing this. I wish I had a camera inside the fuselage to see if I could actually see the middle. I don't know if the tube's going down or if it's just smiling. But that's how much, and look, this next picture kind of shows it all. That is how much my wing flexes under load. How freaking cool is that? So now I want us to watch the video, okay? And so basically in this video, and I'll freeze it at the end, it shows it at normal speed, and then it shows me slowing it down. And it's really amazing how this system bends. But see, I want the carbon fiber to bend. The reason I want the carbon fiber to bend, because carbon fiber has extreme resiliency, if I said that right. And the balsa wood over time, as it flexes and flexes and flexes, it can start to make glue joints come apart. Now, I love tight bond and I use epoxy. I've never had any of those really come apart from fatigue. CA I have a little bit, and that's going to be a different test video. But as you watch this, it's really interesting that the system is working perfectly. I mean, exactly the way, look, and I don't want to say I designed it with math and everything. It's my experience of doing this, you know. I always joke I've been doing this before Jesus had a paper out. So the thing is I love seeing what's going on in my aircraft. And it shows to me, the plane's a lot more safe than a lot of people thought it was. Because I remember when everybody was the naysayers when I was building this wing going, you're going to really fly that with that balsa wood wing? I'm like, hell yeah, I'm going to fly it. Now keep in mind, the first 5 or 10 flights, I kept it away from people. I did some pretty high G maneuvers to see what went on. I landed it. I looked to see if the monocoque had stretched or wrinkled. I looked to see if any visual or visible parts had cracked or maybe deformed, and nothing had happened. So I hope you enjoy this video, everybody, as much as I love making it, because I love dissecting what's going on with my plane. And I'm not out to prove people wrong. I'm out to help people understand, okay? I know a lot of the haters that said this wing would never work. I don't know what they're saying right now because the wing worked. I've got 112 or 14 flights on this airframe now. And I'm not out to try to be a jerk. I'm not out to prove people wrong. Show me your data. Show me your success. I want to learn. I want all of us to learn. If you use carbon fiber in bulkheads and you used it in ribs and you used it in all these things, and if it's cheaper than wood, if it's cheaper than monocoque, if it's cheaper than all those things, share it with me. I want to see it. I'm always wanting to learn. So just like people said my wing would never work, for me, I've never gotten carbon fiber to work in anything except laminating spars and stuff like that for strength. in landing gears, but I don't want to open up that can of worms right now because most people assume when they think of a carbon fiber landing gear, I made hollow landing gears and they've worked great, and it was for a Brewster Buffalo. So everybody have an awesome day. Thanks for watching my videos. Please like and subscribe. Please share these, okay? I'm trying to build my YouTube and get all of model aviation to understand how freaking cool giant scale airplanes can be. Rock on, have a great day, and be safe, everybody. See you next time.